here's our demonstration of our game. If you press the middle button, it starts our game. So right now the WASD and the arrow keys are what let you control the characters, and so you can play them separately and they don't interrupt each other. Up and down is the up and down for the paddle, and if you press the left key on either side, the ball will stop moving. Or sorry, the paddle stops moving. The right key doesn't do anything, and then you can see right now we have a lives counter on the FPGA. So right there, I just updated because the ball fell off the screen on my side, and then the ball's gonna fall off the screen on the left side now, which will drop it down to 2 lives. We'll just let it fall one more time. And then we have a second mode where if you flip the switch right here up, it creates this wall in the middle so that each player can play against themselves. This is a practice mode. It lasts for 5 hits off of the screen. So once the ball falls off 5 times, the practice mode will stop working, just to give you a little ability to practice. If you look at the lives, you can see that the lives are still the same. Little feature we have, you press the middle again, it becomes blue now. And then you can flip it back and you can see we have resumed the original game, and our lives are still the same. So this one we're just gonna let it die and then show you our end game, and that's our project. There you go.
Hello, so I'm Derek, and I work mainly on the modes and the top level module. So here we see our top level module, which our board inputs and keyboard inputs feed into. And we have a clock reset button. We have our PS2 keyboard inputs. We have a mode change input and a switch for the practice mode. We also have outputs for the VGA display, 7-segment display as well. As we go down, we have separate VGA outputs for the different game conditions we're in. So that is the Pong game, start menu, and game over screen. We also generate the vertical and horizontal syncs for those as well. Then we have the 7-segment display outputs, as well as the 2 players' lives in Pong game, as well as the end game flags and the current mode we're in. We instantiate a PS2 keyboard module to take in the keyboard input, a clock divider to divide the board's clock. And then we instantiate the game, which is Pong, and then also the menu screen and the game over screen right here. We also have a module to output these the 2 players' lives onto the score, the 7-segment display. And we also have an incrementer, which changes the mode we're currently in based off a button input. And this last always block essentially takes in which mode we're in and outputs to the display, the VGA display, depending on which mode we're in.
Okay. I'm Lewis. I will talk about the game module and then go into detail about the paddle and the keyboard functionality of our code. So starting with our game module, it takes a lot of the same inputs as our top module. You can kind of see it's the exact same inputs and outputs for the most part. The only real differences are just lives 1 and lives 2 outputs, which we're going to end up using for our real system, which is a live-based system, which is different from the 2020 project that we worked on, which was using every time you hit the paddle, you would get 10 points, and ours is a lives-based system. Here are all of our parameters and registers and wires that we have to use to instantiate everything inside our game. Kind of going into the instances that kind of run our game, we have our display instance, and so this is the actual VGA and what allows us to display onto the screen. We have these rocket modules, which are basically our paddles. These paddles I'll go into a bit more detail. Here we have a couple different types of squares, which are our balls for the game, and so some of my team members will talk about that a bit more later. This always block covers the edges of all of our instance or all of our objects, and then this final always block will go into the colors of our objects. Going into the rocket a bit more, the big differences that we made were we have this key code function which comes from our PS2 receiver. The key code is like an 8-bit number that tells you what key we're using, and so the major change that we made was our movement here, as you can see, is dependent on the keyboard. And then down here, based on what key you did, it changes your movement and allows you to move either up or down. And a big feature that we have is that you can do two players because by separating the movement and the button press, we're able to do two players without interrupting each other. And I think two-player input was a big issue before. And that kind of covers the paddles and the actual game itself.
Hi, I'm Javesh. I mostly worked on the square collision module. Um, so essentially in the 2020 Pong game, people had a collision which was a horizontal collision. So the paddles were horizontal, and then the square only had to go through the top edge of the paddle. And if it hits that, then the square bounces back. But we had two paddles and we had horizontal collision. So we had to rewrite the entire thing. Over here, we're basically taking the input X and Y coordinates of the two paddles that we have, one on the left side, the other on the right side, which represents two different players. Once we give an initial X and Y speed to the ball, and an initial X and Y position. So once the ball reaches to the left end of the screen, what happens is that we trigger the end game flag, and we are assuming that there are no walls over there. So once it reaches the leftmost side of the VGA display, then we reset the conditions again, which is over here. Similarly for the right side, once we reach the right side of the wall, we again initialize all the conditions. Based on that, we detect most of the collision over here through this code. So this code essentially does is that if the left side of the square ball touches the right side of the paddle, which is on the left side of the screen, then we have a collision, and it will essentially change the X direction of the ball. And similarly, if the right side of the square touches the left side of the paddle, then it will again change the X direction of the ball, and then the ball bounce back.
I'm Cohen, and I was working on changing the score parts into lives for our Pong game. I was also in charge of pushing it into the 7-segment display. So building off Javesh's square module, this is where we're going to increment the lives. So basically we have lives 1 and lives 2 here. And we made a variable within the module as L1, L2, and we set those equals to 5. So 5 lives for each player at the beginning. As we go along, I built off Javesh's boundaries. So basically when it detects the rightmost side, it will decrement the lives 2, so L2. And then it's really important that we are detecting when lives 2 or lives 1 later on down here when it reaches the left edge. We're checking that when it equals to 0, it's going to trigger that endgame flag. And then finally at the end, we are setting lives 1 and lives 2 from those variables that we made in the module. It's really important that we do that here because we are actually driving these lives, these changes up into the 7-segment. So over here, this is where we're going to receive those informations from that square. And coming down to the 7-segment display, this is where we're going to drive lives 1 and lives 2. And for our project, we built off of the old 7-segment display, but since they did not have a high score working, I found a way to display 2 different scores. And one noticeable difference is we are driving it to the left edge and the right edge. So player 1 is on the very left segment and player 2 is on the very right.
So going back to the top level module, we see that we have our 3 kind of screen modes. We have our Pong game, we have our menu screen, and we have our end screen. And these output to separate VGA channels, which are then chosen in the always block here. We can go look at the how the menu screen works to display the start screen and game over screen. You'll see that essentially we're loading a memory file that we see right over here that we generated with a third-party tool from here. And essentially this loads into our memory module SRAM. And once we load that in, we take the values of that and read it into the color and VGA display up here.